Let's now code our next program. Using pointers, interchange the values of two integer variables. This is the code. I save it as 31.cpp. We declare three integer variables, var1, var2, and t. var1 is assigned 100. And var2 is assigned 200. We then declare two integer pointers, ptr1 and ptr2. Next, ptr1 is assigned the memory address of var1. Then ptr2 is assigned the memory address of var2. We now print the values of var1 and var2. Next we are going to interchange, or swap, values within the variables, var1 and var2. Remember that ptr1 is pointing to var1, and ptr2 to var2. As per lines 15, 16, and 17, we first temporarily assign the copy of value pointed by ptr1 to location t. Then the copy of value pointed by ptr2 is assigned to value of ptr1. Finally, the value placed in temporary location t is assigned as value of ptr2. We next print the values of var1 and var2. So we just interchange the values of two variables, using the pointer operator. Let's next learn more on the dynamic memory. We have been using fixed memory size that was made available as per variable declaration at the start of a program. But what if we need different memory size depending upon the requirement during program execution, or at runtime? The answer is dynamic memory. For example, the size of an array to collect all student names in a school may be 3,000, it could be 150 for teachers' names, and 20 for the administration staff. Normally, in a computer program that collects all names based on category, an array can be declared, or created, with suitable memory size, after a user has provided the category, be it for student, teacher, or the admin. Advantage is that, you don't waste memory space by declaring a fixed memory size of 3,000, and then proceed to collect the names of just 20 admin staff. At real time, the program decides to allocate memory space to collect 3,000 student names if it is for students, and if it's for the admin staff, only 20 memory spaces are reserved. Dynamic memory is the memory allocation process of allocating memory space during the time of program execution, also known as runtime memory allocation. In C++, dynamic memory is handled by the operators new and delete. The operators new and new array, or new with square brackets. The new operator is used to request dynamic memory allocation. It is followed by a data type specifier, and the total number of memory locations to be allocated within square brackets. It returns a pointer to the beginning of new block of memory that is allocated. General syntax is pointer equals new type, or pointer equals new type, within square brackets, number of elements. Let's have a look at this example. We first declare a pointer to integer, named age. We then dynamically allocate memory space for an integer array of 5 elements, and assign the memory location address of its first element, or header, to the integer pointer named age. It simply means that the pointer named age is pointing to the entire array, and that it's placed in the first element. So, the pointer age has access to the first value. Each element may have specific values stored within it. How does the pointer access value within each location? Let's first note the header address, or address of first location of array pointed by age. It is 0x861530. Applying pointer arithmetics, age plus 1 would mean, let the pointer age proceed to next block of memory. Since we have allocated an integer array, the next memory block would be 4 bytes away. That is, at 0x861534. So now, the pointer points to second array element. Similarly, rest of the memory addresses are all 4 bytes away. Remember that addresses are represented in the hexadecimal format. So 0 to 9 are same as decimals. Number 10 will be A, 11 is B, 12, C, until 15, which is F. So age plus 2 would point to the third element of the array, and age plus 3 would point to fourth element. Let's assume that the pointer is pointing to age plus 2. So it's in the third element. Now, age plus 2 minus 1 would simply mean, go backwards by 1 memory block, or by 4 bytes in this case. Pointer arithmetic is just as clear and easy as this. Are you still wondering about the difference between declaring a normal array and assigning dynamic memory to a pointer, as we have just done? The most important difference is that, in arrays, the size of array has to be a constant value, which limits its size to what we decide at the moment of designing the program, before its execution. In dynamic memory allocation, we can assign memory during execution of the program, that is, at runtime, using any variable or constant value, as its size. You can also start with 0 size, and then add new memory blocks simultaneously. In this example code, a pointer to integer named age is declared. We then allocate memory for an integer array with 0 size. We next assign value 99 to the second array element. And in next line, we assign 151 to the sixth array element. You can print these values. What did it signify? You declared 0 size array along with the new operator, but you could add element values to random locations. Dynamic memory that is requested by our program is allocated by operating system from the memory heap. Note that local variables are stored in memory stack, and dynamic memory is allocated from memory heap. However, computer memory is a limited resource, and it can get exhausted. Therefore, it's crucial to have some mechanism that checks if our request to allocate memory was successful or not.